Hello guys, today we're going to be simplifying radicals. Make sure that you do title your notes, simplifying radicals. This is a prerequisite skill for the unit we're about to do. Hopefully this is review. If not, that's fine. That is why we are reviewing it. So these are notes. Have your notebook out. Make sure you're writing this down. So let's start with an example. Let's write down example number 1. Okay, so example number 1 is we're going to simplify something very simple. The square root of 25. And I hope that we realize that the square root of 25 is the same thing as 5 times 5. Notice that these are my prime numbers and there's 2 of them. So therefore, when I take the square root, the answer is 5 because 5 times 5 gives me 25. And then for the second example, example number 2, it's the same thing. 16. What two numbers multiply to give us what number multiplies itself to give us 16? It's 4 times 4. Notice that there's 2 pairs of them, so therefore the answer here is 4. The pair of 2 come out as 1. So now let's try a different example. Let's try example number 3. And of course we're going to be simplifying radicals without calculator. So let's try the square root of 8. Okay, square root of 8. What we're going to have to do here first is we're going to have to factor completely the 8. So let's factor it completely. Please be writing this down as we go. That way you have reference. So how does 8 factor? We're going to do the factor tree where we're saying 8 is 2 times 4. 2 is a prime factor, so it can be factored no more. And then 4 can be factored a little bit more. 2 times 2. And now 2 and 2 are prime numbers. So that means that 8 can be written as the square root of 2 times 2 times 2. If we notice here, we have one pair of 2's. This one pair of 2's is going to come outside of the radical, and we're left with just this 2 that did not have a pair. So this is how we simplify the square root of 8. All right. Now let's try another example so that we can understand exactly what I'm doing. Let's write down example number 4. And let's do a larger number such as, let's go with 75. The square root of 75. All right, so the first step we want to do here is we want to factor it out completely. So I'm going to draw my factor tree to the side over here. This is what we call a factor tree. So we got 75. Okay, so we want to factor it completely. The best way is to choose the smallest numbers first. For example, the 75. Can I divide 75 by 2? No. Can I divide 75 by 3? I can, because 3 times 25 gives me 75. Okay, and here we notice that 3 is a prime number, so I can't do anything else with it. However, 25 factors down to 5 times 5. And those two are actually prime numbers, so I can't factor it anymore. Therefore, 75, the square root of 75 can be written as 3 times 5 times 5. Now here, when we take the square root, we want to know what number times itself we can take out. Here we got 5 times 5, so that means I can take out 1 5. I can't take out the 3 because the 3 does not have a pair. So the square root of 75 simplifies down to 5 over the square root of 3. 5 times the square root of 3. Now let's go ahead and try example number 5. And this one's going to be a little bit different. Let's take the square root of 180. Notice that my numbers have gotten bigger. Oh, it's horrible writing on the screen, guys. 180. Again, I like to start with the smallest number first and then work my way down from there. So 180, I'm going to divide it by 2. 2 times 90 gives me 180. The 2 is prime, so I can't factor that anymore. However, the 90, I can factor that some more. I can divide it by 2, so that's going to be 2 times 45. Again, my 2 can't be factored anymore, so I'm just going to let it be. The 45, I can't divide it by 2, but I can divide it by 3. That's 3 times 15. So I have a 3 that's primed. The 15, I can divide it down, factor it down to 3 times 5. So I'm going to do 3 and 5 are prime. So now I'm going to rewrite this radical. The square root of 2, there's my 2, and another 2 times 3 times 3 times 5. Now this radical is a little different because notice that I have a pair of 2's and I have a pair of 3's. That means that a 2 can come outside. So a 2 is going to come outside of the radical. And a 3 can also come outside of the radical. And the only thing that's left in the radical is this 5. Now, what happens between this 2 and the 3? Between the 2 and the 3, they're all multiplying on the inside, so they're multiplying out here as well. So we're going to have 2 times 3 is 6. So the 6 times the square root of 5 is 100. The square root of 180 simplified. Okay, so now that we've simplified a bigger radical, let's review one last thing as well. Let's do example number 6. And I hope you're writing down all these examples. I will be checking for them later on. And if you need to pause the video and take the notes, please feel free to do so. Okay, so now we're going to simplify the square root of 6. Notice that 6 is only 2 times 3. Those are its prime factors, and it doesn't factor anymore. So that means that this can be written as the square root of 2 times 3. I don't have any pairs. So the square root of 6 is already simplified. Is already simplified. So I can't do that. Now this is your classwork. Make sure you write this down and simplify the following radicals. Okay, this is your classwork. Number 1, simplify the square root of 24. Number 2, simplify the square root of 28. Number 3, simplify the square root of 80. Number 4, simplify the square root of 125. Number 5, simplify the square root of 26. Number 6, simplify the square root of 216. Alright, so this is your classwork, guys. I will be checking to make sure that you have done all of this.